Bismillah Rahman Rahim. Assalamu alaikum, dear students. I am Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access course page on my personal website, arif.me. You can click the appropriate link under the lecture resource column over here. The net is a bit slow today. Well, anyway, once this opens up, you can click the appropriate link to view the notebook in NB Viewer and run it online in Binder. And the other way is to download this notebook from the course GitHub account, Arif PUCIT. And all the notebooks for this course are housed in the public data science repository. This is the Jupyter Notebook dashboard running locally on my machine at port 8888. And here is the notebook for today's session, lecture 3.18 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. Well, my dear students, this is the 10th session on Pandas, and today we are going to understand the concept of merging, joining, concatenating, and appending data frames. This is probably the most important and common task that you normally do in Pandas after indexing, slicing, and group bys, which we have already covered. Well, there are 4 ways to combine data frame. Merging using pd.merge method, joining using df.join, concatenating using pd.concat, and appending using df.append. Well, I have divided today's session in 2 parts. In part 1, we will practically understand the merge method and the 4 types of join. The join method to me is a bit redundant. All the tasks you need to do can be performed using merge. In part 2, we will practically understand the concat method, which can concatenate 2 data frames on both the axis 0 as well as 1. That is, concatenate horizontally as well as vertically. The append method is again, I think, redundant. However, can be used if you want to append only along axis is equal to 0, that is horizontally. Okay, let's start with the merging and joining, and we will be using the pd.merge method for that. My dear students, merging or joining data frame is a concept very commonly used in relational databases as well. This Pandas merge is a versatile method to perform all standard database join operations between data frames or maybe named series objects as well. The only 2 requirements to this method are the left and right, which are the 2 objects to merge. The third argument, how, specifies the type of join, which can be inner, left, outer, or right, and the default is inner. Well, this on argument specifies the column name to join on, which must be there in the left as well as in the right data frame. This indicator argument, if set to true, will add an additional column in the output data frame with the name of underscore merge with information on the source of each row, and can have 3 values: left only, right only, and both. And we will talk about the suffixes as well as the validate argument after doing a bit of practice on merging. Okay, so let's start with the inner join first. Well, it is the most common type of join and is similar to the intersection of 2 sets as shown in this diagram. Consider 2 data frames, one containing the temperature of 4 cities, Lahore, Murree, Peshawar, and Sialkot, and the other containing humidity level of cities, the same cities. Note in the humidity data frame over here, the humidity level of Sialkot does not exist, while over here we do have the record for Sialkot. Moreover, over here we have two records for humidity level of Lahore, and finally we have the humidity level of this Karachi city, but it does not have the corresponding record for in the temperature data frame. Well, I have intentionally designed these data frames as such to have a clear understanding of all the concepts, all the related concepts. Let us suppose that we merge these two data frames using this line of code. With the left data frame as the temperature data frame and the right data frame as the humidity data frame. The column on which we are merging these two data frame is the city column, and of course which do exist in both these data frames. And finally, this how argument is mentioning that we are performing an inner join, and we have also set the indicator flag to true. So how does it proceeds? My dear students, it will first look at the first value of the key column, that is the Lahore city in the left data frame, the temperature data frame, and will join it with two records of Lahore in the right data frame, that is the humidity data frame. You can observe the two rows in the resulting data frame. It will then look for the second value of the key column, that is the Murray in the left data frame, that is the temperature data frame, and will join it with the only record of Murray city that exists in the right data frame at index 4. And you can observe the new row added in the resulting data frame over here. It will then look at the third value of the key column in the left data frame, that is the Peshawar city, and will similarly produce a combined record for Peshawar in the resulting data frame. Finally, the fourth value in the left data frame on the key column city, that is Sialkot. We do not have a corresponding record of Sialkot in the right data frame, so that is omitted. So this is what an inner join is and how it proceeds. Finally, do note the additional column named _merge in this resulting data frame, mentioning the source of each row, which is in all these cases both. That is, in this case being an inner join or intersection, all these records exist in both these left and right data frames. So this is it. Let's do this practically. Over here I have created a simple data frame, the exact same replica using this dictionary, the city column and the temperature column. So this is the temperature data frame, and this is the humidity data frame. Well, as usual, see the city column is common in both, on which we want to perform the inner join. So this is the syntax which we have discussed on the image as well. We are performing an inner join on these, and this is the resulting data frame. For completeness, over here I have just swapped the left and right data frame. Instead of the temperature data frame as the left data frame, over here I have placed the humidity data frame as the left and temperature data frame as the right. If you observe, more or less all the same records are there in both of these output data frames. However, the sequence is a bit different. This sequence I have discussed on the image, how this will be produced. And on the same grounds, if you keep the humidity data frame as the left data frame and run the same sequence, you will exactly get this over here. You can see Peshawar is before Murray. Okay, let us move on to the next type of join, and that is the full join. also known as the full outer join, which is similar to union of two sets as shown over here. For simplicity, I'm using the same two data frames. Note the two additional rows in the output data frame this time. Since we do not have corresponding record of humidity for Sialkot city, note over here we have NaN under the humidity column against the record of Sialkot city. Similarly, since we do not have a corresponding record of temperature for the Karachi city, note the NaN value under the temperature column. And do note the underscore merge column. For this Sialkot city, we have left only, means that this element is present only in the left data frame. And similarly, over here you can see right only. This means that this record is present only in the right data frame. Hope this all is making sense. Let's see this practically. Once again, these are the two data frames. And over here I have just mentioned outer. So this is the result. See, this is the union of these two data frames. Note the NaNs and the underscore merge column. Over here these four records are present in both the data frames, while this record of Sialkot was present only in the left data frame, that is the temperature data frame, and this Karachi record is only present in the right data frame, humidity data frame. Note the NaNs as well. And over here as well, for completeness, I have swapped them, the left and the right data frames. You can see the same records, however the sequence may vary. Okay, let's move on to the third type of join, and that is the left join or the left outer join as well. Well, this simply performs an inner join plus all the non-matching rows of the left data frame. Over here in this case, this temperature data frame will be part of the output data frame. Note over here the Sialkot record in the left data frame, which is not there in the right data frame, is part of this output data frame. And note this NaN value as well for the humidity column. And moreover, the record of Karachi city from this right data frame is not part of this output data frame. So this is a left join. Let's see this practically. So these are the two data frames on which we want to apply our left join. Note this is a left join. Well, my dear friends, left join and right join also depend on the order in particular. Over here, once I swap these two data frames, you will see different results. Note over here, this temperature data frame record Sialkot is there in the resulting data frame, and over here the left data frame is the humidity data frame. So that's why you see the Karachi record over here. I hope this is clear to you. Okay, let's move on to the right join, the fourth type of join. This is also known as the right outer join. Well, my dear friends, this simply performs an inner join plus all the non-matching rows of the right data frame. Over here the right data frame is the humidity data frame, will be part of the output data frame. Note the record of Karachi is there over here with the NaN column under the temperature, and the record of Sialkot from the left data frame is not there in the output data frame. So this is the right outer join. Once again, let's see this practically. These are the two data frames on which we want to perform our right join. The temperature is the left data frame in this case. So you see the record of Karachi is there, since this is a right outer join. And if I replace these, swap these two, over here the left data frame is the humidity data frame. So you see we have the record of Sialkot in the resulting data frame and not of Karachi. Hope this is clear to you all the four types of joins. So let me move on to the part two, not part two, rather let me discuss certain additional parameters to the merge method. When one is suffixes parameter. Well, my dear friends, this suffixes parameter is used to give or append suffixes to the column labels. Let me explain this or describe this practically to you. Consider these two data frames. This data frame contains the temperature and humidity of these three cities. And this data frame also has temperature and humidity of these three cities. In this data frame, we have the record for Lahore, Karachi and Peshawar city. And over here we have the record for Karachi, Peshawar and Islamabad city. So in this data frame, we do not have the record of Islamabad, and over here we do not have the record for Lahore. Now let's suppose that I simply perform a merge, inner merge, and let's see the output. Note that this time this merge has automatically appended suffixes with column labels. Since we have the temperature column and the humidity column in both the data frames, so it has appended an X with them and Y with them. This temperature underscore X means the temperature of the left data frame, and this temperature underscore Y means the temperature column of the right data frame, and similarly this humidity as well. And note, since this is the inner join, so only the intersection of these two, that is Karachi and Peshawar, these two records are here. The point which I want to mention in this example is basically this suffix. We can change these suffixes by passing the suffix parameter to the pd.merge, which I have used over here. So instead of using the X and Y I have mentioned left and right, you can use any strings of your own choice. So this column shows the temperature from the left data frame. This column shows the temperature from the right data frame. So this is the use of the suffixes argument to the merge method. Other than suffixes, there is another argument that is normally used, that is the validate parameter. And the validate parameter is used to check for uniqueness of the keys in these two data frames. Let's suppose that this time we again have these two data frames. This data frame has the column city and temperature, and this has the column city and humidity. And let's see that we want to check that there should be a one-to-one mapping of the merge keys. Let me show you these again. Okay, so I need one-to-one mapping, that for every key over here we have a single key over here, but over here you see for Lahore we have two records of Lahore in the right data frame. So one-to-one mapping does not exist between these two data frames. So if I do something like this and pass validate an argument of one-to-one, this will flag an error. And the error says merge keys are not unique in right dataset. This is not a one-to-one merge. So one-to-one merging is not possible over here. Let us see one-to-many. And naturally one-to-many will work, because for Lahore over here we can have multiple Lahores over here, and this will work. So validation of one-to-many will not raise an error over here. So this will be a success. And the merging is same. We have just performed outer merge. Over here I'm just trying to let you know that you can use this validate parameter, and to this validate parameter you can pass four different arguments. And the first argument is one-to-one, which checks the merge keys are unique in both the left as well as the right data frame. If not, then it will throw a exception. The other can be one-to-many. in which case if the merge keys are unique in the left data frame, it's okay. And the third is many to one, and in case of many to one, it will check that the keys should be unique in the right data frame. And over here, once again, the keys are not unique in the right data frame since we have two Lahores over here. So this will again flag an error. And the error will say merge keys are not unique in right data set. I hope this is making sense. And finally, we have many to many. In many to many, there are no checks, of course. We can have multiple keys or multiple records for Lahore or Karachi or Murray over here as well and over here as well. So this will work perfectly fine. So this is the validate parameter, which can take 4 arguments: one to one, one to many to one, and many to many, and checks for the uniqueness of the keys in any of the data frames. Okay, we are done with part 1. My dear friends, like merge and join methods, the concat and append methods are also quite similar. The append method can only append two data frames along axis is equal to 0 or horizontally or row wise, that is placing one data frame below the other. So if you just want to join two data frames vertically up and down like this, you can use append as well as you can use concat. The concat is more powerful as it allows you to concatenate two data frames on axis 1 as well, along axis 0 as well, and along axis 1 as well. That is vertically or column wise. That is by placing one data frame on the right of the other. So I think this concat is more powerful. So let's start with pandas concat method. The only required argument to concat method is the list of pandas object that you want to concatenate. The default values are mentioned ahead. Let's start doing it practically, and one by one we will understand these parameters as well. So let's suppose that we want to concatenate two columns row wise, that is along axis is equal to 0, that is one below the other. So for this I have these two sample data frames. Let me show you these two data frames. So we have this data frames having the city, temperature and humidity column, and another data frame having city, temperature and humidity column. And let's suppose that these are the cities of Pakistan: Lahore, Karachi, Peshawar, Islamabad and Murray. And these are the 4 cities of UAE, Dubai, Sharjah, Ajman and Abu Dhabi. And we just want to concatenate these two data frames one below the other. So the only required argument is a list to pd.concat, and that list contains any number of data frames. Over here we have 2. If you do not pass this axis argument, the default value is 0. That is, by default 2 data frames are joined vertically, that is one over the other. Let me run this. Excuse me. So you see they have successfully been concatenated. Note the index over here, they are also concatenated as such. And if you want that the index should be from 0, 1, 2, 3, 4, 5, 6, 7, 8 and so on, then you need to pass the ignore index argument. You need to pass true to this argument, and that I have done over here. Let me run this. So over here you can see the indices are going from 0 to onward. Great. I hope this is making sense. Other than this numeric index, my dear students, if you want to have an additional index for subgroups, for example, we see that this is a subgroup for the temperature and humidity levels of cities of Pakistan, and this is a subgroup for the temperature and humidity level for the cities of UAE. So we can create the subgroups over here as well, and that can be done using the keys argument to this pd.concat method. And to the keys argument we can pass a list containing the subgroups. So let me run this, and you see the magic. We have now the 2 groups. I think if you have seen the group by series of session, group by session on pandas, you can easily understand the advantage of this. And the advantage of this is that we have now two indices related with this data frame. This is the outer index containing the country names, and this is the inner index. And since now Pak and UAE are indices, so you can use them as an argument to lock. So you see, we have got just the sub data frame from this bigger data frame containing the temperature and humidity of the Pakistan city only. And over here we have got this. This might seems quite intuitive to you. However, just consider that if there are 150 different countries of the world and having a lot of cities, and if you group them like this, it will be really attractive and really easy to work with. Okay, now next question is what happens if one of the data frame has an additional column. Over here you have seen that both the data frames which we have concatenated have city, temperature and humidity, these three columns. Now the question is what if we have different columns? So let's see these two data frames now. My dear friends, this is once again a data frame having city and temperature of different cities of Pakistan. And over here we have a data frame containing city temperature as well as the humidity level of different cities of UAE. So we have an additional column over here which is not there in this data frame. Now what will happen if we concatenate these two data frames? So this have been shown over here. Well, you can observe that there are NaN values under the humidity columns for all the cities of Pakistan because their records does not exist over here. I hope this makes sense. Okay. Fine. Concatenate method can be used to concatenate two data frames side by side as well. That is, along axis is equal to 1. My dear students, it is normally not advised to do this like this. That is column-wise concatenation. However, if you want to do it, you need to keep two things in mind. That these two data frames, the rows of these two data frames must be same. That is, if this data frame has 4 records, this should also have 4 records. And moreover, the indices of both the data frames must be sorted. Let's see this practically. So we have these two sample data frames. Once again, the temperature of different cities of Pakistan, and over here we have wind speed for different countries of Pakistan. And note that we have Lahore, Karachi, Peshawar, Islamabad and Murree, and over here as well we have Lahore, Karachi, Peshawar, Islamabad and Murree. The same cities are there and the same cities are over here. Let's concatenate these two data frames column wise. So we just pass a list of the two data frames, and the only difference over here is that we have passed axis is equal to 1. That is column wise concatenation, and see the output. You see, it seems perfectly fine right now, at least to me. If you think that this city column is additional, you can just drop it. But the question is, what will happen if we have missing data in our data frames? Let's see this example. Once again, I have created two data frames. These data frames have records for Karachi, Peshawar, Islamabad and Murree. And over here we have Lahore, Karachi, Peshawar and Murree. So you can note that in this data frame I do not have the record for Islamabad. Yes, we do not have the record for Islamabad, which is here. And over here we have Karachi, Peshawar, Islamabad and Murree. So over here we have 4 records, and over here we have 4 records. Over here the additional record is Lahore. Over here we have Lahore, an additional city, and over here we have Islamabad, an additional city. So we have once we will concatenate these two, we will have missing data. And you see that it has just concatenated Karachi with Lahore. Karachi temperature 39 and Karachi wind speed 12. Instead of coming wind speed 12 over here, we have the record of Lahore over here. So what it has done is it has just combined them like this. This 0 Karachi has been joined with 0 Lahore. This 1 Peshawar has been joined with 1 Karachi. So this doesn't look good. So we have missing data or misplaced data in this data frame, and to solve it we need to align the rows, and to do that we need to create an index for each data frame. Note over here I have used the index argument. In the first data frame I have just mentioned the index as 0, 1, 2, 3. 0 for Karachi, 1 for Peshawar, 2 for Islamabad and 3 for Murree. Note this data frame. I have created the index manually. Over here I have created the index in a particular fashion. You see, Lahore has the index of 4 and this Karachi has the index of 0, which is the same as over here. Peshawar has the index of 1, which is the same over here. Murree has the index of 3, which is the same over here. So now they will be concatenated as per the index. You see, this time you will not see any problem over here. This Karachi record temperature and wind speed are in the same row. Similarly Peshawar. And for Islamabad, of course, we do not have the wind speed, so we have NAN over here. Okay, so remember this concatenate normally perform a union, so data is preserved. So this Islamabad record has not been dropped. Rather, we have a NAN for the wind speed of Islamabad. Great. Right, the way we can concatenate two data frames, we can concatenate a single row or a column with a data frame as well. And that has been shown over here. Let's suppose that we have this data frame and I have created another data frame having only one record of Multan, and I'm just concatenating them. You see the record of Multan has come over here. And of course note the ignore index, that is why this is 5. It would have been 0, even then it would have been 5 over here because of this ignore index argument. And because of axis is equal to 0, they have been concatenated vertically up. This data frame has been just concatenated with this data frame, one over the other. At times you will like to place this particular row at a particular place. By default, whenever you will do concatenation, this data frame will just be placed over here. Let's suppose we have a single row and we want to place it at an appropriate index over here. This is a technique to do that. You see, let's suppose that I want to place this Multan record after this Karachi. So what I have done is I have concatenated the first two rows 0 and 1 of df1, then I have placed df2, and then I have placed the remaining rows of df1. So this way, once I will run it, you will see Multan will come up over here instead of coming at index 5. So this is one way at times student to ask that what if we want to place a new record at an appropriate place instead of placing it at the end. So this is one way of doing it, that is using slicing. Okay, similarly you can add a column to a data frame as well. Let's suppose that we have this data frame having 3 columns: city, temperature and humidity. And let's suppose that we just want to add another column over here. So for that you can just create a series. So I have created a series having 0, 1, 2, 3, 4, these 5 records for these 5 cities. Let's suppose this is the column named or series named event, and I want that the Lahore, the record for Lahore over here should say humid, Karachi should say dry, Peshawar rainy, Islamabad humid, and Murree again rainy. So I have created this series, and now I am concatenating along axis is equal to 1. You can see it has concatenated. So I think we have done this in some previous session as well. But anyway, okay, my dear students, that is all about concatenate. Although you can concatenate two data frames along both the axes, along 0 as well as along 1. However, appending data frames is another easier way of appending two data frames vertically, that is one over the other. So you may use append as well. Uh, this is just an additional technique. So once again, just for completeness, I'm teaching this. Consider these two data frames. Once again, the data frame containing the weather of different cities of Pakistan, and the data frame containing the temperature and humidity of different cities of UAE. And this time I'm using append. You see, once again, note the indices, and you can of course over here as well, you can pass the ignore index is equal to true. This will adjust the indices as well. So this is what append is. You can always append a single row as well. Let's suppose the way you can do it with concat, the similar way you can do it with append. But remember, over here we have a data frame on the left of the append method and a data frame on the right of the append method, instead of passing both the arguments inside the bracket. So this is a difference between the concat and append. Remember, we call concat as pd.concat and pass the two data frames in between. And for the append, there is one data frame on the left which calls this append, and we pass this data frame inside it. Okay. So I think this makes sense. Okay, so we can have this example as well. You see, this is the record for Sal code. So we have appended Sal code over here, and if this record has a new column, let's suppose this some new column 66, which does not have corresponding values in this data frame park weather, so we will have NaN over here. So these are the points you need to keep in mind whenever you are concatenating or appending different data frames. Fine. Okay, my dear students, that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next sessions. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.